Hi, this is King of Review. In this problem, we want to solve the system of linear equations using Cramers Rule. So if we have two equations that are in the form ax plus by equals e and cx plus dy equals f, then we can use a method called Cramers Rule to solve for x and y. So Cramers Rule is a method where we use determinants to solve the system of linear equations. Cramers Rule states that x is equal to the determinant of the x matrix divided by the determinant of the coefficient matrix. And y, this is equal to the determinant of the y matrix divided by the determinant of the coefficient matrix. So let's set up our matrices. Let's start with our coefficient matrix. Well, the coefficient matrix, this is going to equal the coefficients on the x and y terms. So we have A, B, C, and D. Now the x matrix, this is going to equal E and F. These are the constants. And then B and D. And our y matrix, this is equal to A, C, E, and F. So this is how we set up the matrices. Let's do that using our specific values. Let's start with the coefficient matrix. So what are the coefficients? Well, we have 5, -1, 9, and 2. 5, -1, 9, and 2. Now let's set up our x matrix. E and F, well, those are the constants. So -44 and -83. And then B and D, so -1 and 2. And Y, we have A and C, so 5 and 9, and then E and F, -44 and -83. So you notice with Cramers Rule, when we solve for x and y, we need to find the determinants of these matrices. So how do we do that? Well, if we have a matrix with A, B, C, and D, the determinant is going to equal the product of the entries in the main diagonal, so AD, minus the product of the entries in the other diagonal, CB. So we have AD minus CB. So let's find the determinants for our matrices. We have the product of the entries in the main diagonal, so 5 times 2, minus the product of the entries in the other diagonal, 9 times -1. And when we work this out, this is equal to 19. Now for the determinant of the x matrix, we have the product of the main diagonal, so -44 times 2, minus the product of the entries in the other diagonal, -83 times a -1. And when we work this out, we get -171. And now for the y matrix. We have the product of the entries in the main diagonal, so 5 times -83, and minus the product of the entries in the other diagonal, 9 times -44. So what does this equal? Well, when we work this out, we get -19. So now to solve for x, we have the determinant of the x matrix. Well, we solved for that here. That's -171. And this is over the determinant of the coefficient matrix. And we solved for that. That's 19. And when we work this out, this equals -9. So we know that x is equal to -9. And now for y, we have the determinant of the y matrix. We solved for that here. That's negative 19, divided by the determinant of the coefficient matrix, which is 19, and this equals negative 1. So we know that y is equal to negative 1. So now we've solved our system here, and letter A is correct. Thanks for watching.